1834 was Dmitry Mendeleev, a Russian scholar. Mendeleev helped arrange the periodic table of elements by atomic mass. He realized that some used at the time were incorrect and left spaces for new discoveries of new elements.
Okay, so let's take a look at the periodic table. So, if we look here to the right, everything in this section are alkaline metals, and then next to it are the alkaline earth metals. And then everything in pink are the transition metals. Everything in purple are the other metals. Everything in the blue color are metalloids, and then in this green color they are nonmetals, and then in this other light green color they are halogens, which are nonmetals, and then the yellow elements are nonmetals as well because they're noble gases. Okay. Now we're going to talk about covalent compounds. So what are covalent compounds? They are nonmetals interacting with each other.
Oh. Wow.
So now how do we name these compounds?
I don't know. Teach me.
One rule is that the second element will have the suffix "ide" added to it. The other rule is that there will be prefixes based on the subscript.
Oh.
So what are these prefixes? There is mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. But it is important to remember that mono can only be used for the second element. So now let's take a look at an example.
Okay.
So let's say that we have PCl5.
What does that stand for?
We're about to find out. Okay.
Why are the caps? Put the caps on them. What the heck?
So if we remember back to the prefixes, 5 was penta.
Oh.
P is phosphorus. And Cl is chlorine. So now to put this together, the first element does not change. It stays as it is. So it is written as phosphorus. Now the second one, we're going to use this subscript 5 in order to name chloride into pentachloride.
Oh.
Notice how we also changed the ending of chlorine to ide.
Mm-hmm. Clever.
That was good.
Okay.
Now let's take a look at ionic compounds. So, we are going to be looking at cations and anions.
What?
Cations hold a positive charge, while anions hold a negative charge. Now let's focus on them one at a time. Let's first look at cations.
That's still an ugly A.
Okay. So, one type of cation are monatomic ions. In the monatomic ions, they end with ion. Now, if we take a look at polyatomic ions, so in polyatomic ions, the elements end with ium. For example, there is ammonium and there is hydronium. Now, I'm using this one. Okay, now we are going to look at the transition metals. In transition metals, we add OUS or IC. OUS goes to the element that has less charge, and IC goes to the one that has more charge. Now, an example would be iron. Fe stands for iron, and it has two charges. It has a +2 charge, and it has a +3 charge, as we went over earlier. This makes a lot of difference when we are naming the metals. So this one, we can write it as iron 2, the 2 coming from its charge, and then this one we can write it as iron 3, the 3 coming from its charge. But we can also call it ferrous or ferric. And this implements the OUS ending for the less charged and the IC ending for the one that has a higher charge. Now let's focus on anions. So when we are dealing with monatomic, now if we're dealing with polyatomic ions, oh, this is hard. We can add ite or we can add ate.
Ite. Okay.
This is also based on charge. And now an example of this is nitrogen with oxygen. So we have NO with a -3 charge and NO with a -2 charge. So NO with a -3 charge is called nitrate. But NO with a -2 charge is called nitrite.
Oh.
And this happens because of a loss of oxygen. Now let's look at a few other examples. So we have ClO with a -4 charge. We have ClO with a -3 charge. And we have ClO with a -2 charge.
What does CLO stand for? For 20% battery.
So what it stands for...
Oh, yeah. Okay, sorry.
So what it stands for is that when it has a -4 charge, it is perchlorate. When it's a -3 charge, it is chlorate. And when it has a -2 charge, it is chlorite.
Oh. Okay. So now, children, we're going to... Is it filming? We're going to talk about naming acids. Boop. Okay. So, we just talked about, for anions, the 8 and 8 endings. So, what happens when you have an acid is there's usually an extra H plus ion. So this H plus ion, the H stands for hydrogen, and the plus is because it has a +1 charge. So now when this H plus ion is added and this turns into an acid, you change this 8 ending into an ick ending, and this 8 ending into an us type ending. So those are very important. So I will do this. Oh, yeah. Okay. So, now we go into our example. So, let's say that we have HCl, which is, so we have this H ion, which is helping us to know that it's possibly an acid, and it has a charge of +1, and the chlorine has a charge of -1. So, we would call this hydrochlor. Now, here's the thing. Hydrochloric acid. All right? Now, this is because of what we just talked about. Because we would think of it as chlorate, like we had in these other examples earlier, but instead of chlorate, we change it to chloric. Okay? So, another example would be H2SO4. So, the reason we have to have this subscript 2, I know you fucked it up. The reason we have to have this subscript 2 is because this sulfate ion has a charge of -2, and this hydrogen ion only has a charge of +1. Now, to even the charges, you have to have this nice subscript of 2. Okay, so when naming this acid, we would call it sulfur. Now, here's the ending again. Ick acid. And that's the end.